Good morning, Calc fans. How we doing on this bright, sunny Tuesday morning? Beautiful sunshine outside. It's a little chilly though, but at least it's sunny outside. Better than yesterday. All my hair blew off my head yesterday. It was so daggone windy out there. So it's a little bit better being a little bit sunny out there. It's supposed to warm up a little bit. Get you to go outside. Maybe you have to go out and mow the yard for your parents. That would be great. If you need to mow your yard, I hear the mower going outside there right now. I'm going to go out and split wood today, so that's my joy for the day. Today we're going to continue to go with the upper sum and lower sum. We're going to go 2 additional problems. Once again, if you have any questions, please do email me, comment me, and I will go over the next day any type of questions that you have. The left sum and right sum are probably the most difficult as you go through them. Now, as we went through the left sum and right sum, in the homework that you had, there was a question I had at the very bottom. What happens as we decrease that delta x? And what should happen as you start to decrease that delta x, the amount of over and the amount of under starts to diminish. So you're calculating the area of all these little rectangles here. And what you'll start to see as you calculate the area of all these rectangles, the area for the upper limit, the upper sum and the lower sum, they start getting closer and closer together. Okay? Now, we did a delta x of 1, a delta x of 1/2, and a delta x of 1/4. If you made it through the 1/4, good for you. Okay, that's a tough one to make it through. That's a lot of calculations to go through. But if you can make it through that, that's a good thing. But what you see as you get closer and closer, well, what if we had just 1/10, a delta x of 1/10 on that? See how close it continues to get closer and closer together? Or if we had 1/100th or 1/1000th, our delta x is 1/1000th, and we want to calculate every 1/1000th. I wouldn't suggest you doing that. If you want to, that would be great. But you'll see those 2 upper bounds and lower bounds will get closer and closer and closer together. And what that is called a squeezing theorem. Okay, you're squeezing in, you're converging in on a specific value. Okay, so that's what I wanted to show you as you want your delta x of 1 to 1/2 to 1/4. If you made it through the quarter, once again, very good job. It's an exercise of patience as you go through that. And if you have a different piece of paper, that's a great thing to do. But you'll see as that delta x gets smaller and smaller, once again, the amount of overage you have with the upper sum and the amount of underage you have with the lower sum keeps on getting smaller and smaller and smaller. Today we're going to go over 2 problems here in class, one upper sum and lower sum. But we're going to take a look at something a little bit different in regards to things that we have to worry about. The nice thing for you is as I go through these problems and I will evaluate you on these problems, all the evaluations will have a delta x of 1. So we'll keep it as simple as possible. I won't go the 1/2 and 1/4. I may ask you about that, but I won't make you go through the calculations with that. But we'll look at delta x of a value of 1. So if I take a look at, here's my function, an interval from -2 to 3, and I have a delta x of 1. So what I have here in regards to my intervals, okay, if I take a look at the first step I have to do is I have to draw vertical lines at my partition values. Oopsie. There we go. Here's my partition values. Now if I take a look at my subintervals, and I suggest that you write these out, are from -2 to -1, -1 to 0, 0 to 1, 1 to 2, and then 2 to 3. These are our subintervals that we're going to be dealing with here. And my partition values would just be my endpoints, -2, -1, 0, 1, 2, and 3. That's my partition, so I will write them in here. My partitions, I start at -2, -1, 0, 1, 2, and 3. These are my partition values. So I draw my vertical lines of my partition values. Now, the lower sum, okay, once again, what we are trying to calculate is we're trying to calculate the area between the graph of the function and the x-axis. So we're trying to calculate all this area in through here. Should I color that in? There we go. We're trying to calculate all this area between the graph of the function and the x-axis. That's our idea of a definite integral. Well, the lower sum we start out with is we have a delta x of 1. My base is the value of 1. We're once again calculating areas of a rectangle. My lower sum, by definition, I have to draw a horizontal line so that it is entirely below the graph of the function. Entirely below the graph of the function for the lower sum. So what I have to do is use a point on the graph and draw my horizontal line so it's entirely below the graph of the function, which is going to be below the graph of the function. So if I take a look at my interval from -2 to -1, I'll just call this area 1. This area 1, I have a base of a value of 1, and my height is my function value at -2. Now what you may want to do within your function or within your calculator is type in this function into your y1, because we're going to be doing function values here. So in your y1, I'm going to type in 8x cubed minus 9x squared minus 27x plus 3. I'm going to type that into my y1 because I'm going to have to do values of this, and I'm going to calculate my value at a value of -2. Man, I'm getting ears. It's clear out. Now, my calculator must have a virus. There we go. Let's try this one more time. Let's calculate value. There we go, at -2. And I get a value of -43. So we have 1 times -43, which tells me my area is -43 squares. Which now thinks about, well, let's take a look at the area. I have a negative area when I go below the x-axis. I got a negative area here, which is fine. That is fine. Let's look at my region 2, area 2. If I look at my area 2, I need to be entirely below the graph of the function. And I have to use one of these sides here, or wherever I cross the axis, or wherever my graph crosses there, I need to intersect at a point where I have in this region here. So if I take a look, my graph, I need to move this so it's entirely below the graph of the function, which is right there. Okay, once again, I need to stay below, entirely below the graph of the function. If I drew it here, I wouldn't be entirely below the graph of the function. If I drew it here, whoopsie. If I drew it here, I wouldn't be entirely below the graph. But if I drew it, having some problems here. Let me do this first. Let me lock this in place. Lock in place, there we go. I have a tough time grabbing my line. There we go. Got my line grabbed. I draw it there, now it's entirely below the graph of the function. So in my A2, my base is still a value of 1, but my function value is this function value right here, which is my function value at 0. Well, my function value at 0 is a value of 3, so this is 3 squares. This is 3 squares. If I put in my function value of 3 or 0, I get a value of 3. If I look at my next region, A3, once again, I need to draw my line so it's entirely below the graph of the function and intersect my graph at exactly 1 point. So if I intersect and I have to stay below, I have to come from this point here over, which is my function value at 1. So my A3 is my base is still 1 times my function value at 1. So once again, I'm going to go to my calculator, type in the value of 1, I get a value of negative 25. So we have negative 25 squares. Now, let's go to A4. Here's the next little thing that we have to worry about, the fourth region. I need to draw my horizontal line so it's entirely below the graph of the function. I need to stay entirely below the graph of the function. Well, if I look at my function, if I use this point and draw across, I'm not entirely below the graph. Where I have to draw so it's entirely below the graph is at this bottom value, which, if you remember, what do we call that value? That was a local minimum. And I need to know what is my function value at this local minimum. Well, how do I find my x value at that local minimum? That's exactly right. That is a critical point. So I had to take a look at my derivative. So if I have my function here, I have my derivative, which is 24x squared minus 18x minus 27. That is my derivative. In my critical point, we have to set this equal to the value of 0. And what I would suggest you do is find your quadratic formula in your calculator and solve it that way. So I got my quadratic formula. My a is 24, my b is negative 18, and my c is a value of negative 27. I get the value of 1.5 and negative 0.75. Those are our critical points. Those where our local maximum and minimums are going to be. So if I take a look, this will be at negative 1.5. So my A4 is the value of 1 times my function value of 1.5. And once again, if I'm going too fast, hit the pause button. You have a chance to shut me up. So I need to find my function value of 1.5. So I'm going to calculate my function value at 1.5. I get negative 30.75. So we have negative 30.75. And then my last one, I have to stay entirely below the graph of the function. Once again, with my lower sum. So if I draw it here, I'm above, I'm inner, I'm here, I'm here. At this point here, I'm entirely below the graph of the function. So for my A5, I have my function value at the value of 2. So A5 is the value of 1 times my function value of 2. So we have 1 times function value of 2 is negative 23. So we have negative 23 squares. So we do our Riemann sum. Our Riemann sum is we're going to add these all up. So we have negative 43, or we just add down our column here. Negative 43 plus 3 plus minus 25 minus 30.75 minus 23. So we have negative 118.75 squares would be our Riemann sum. Let's take a look at the upper sum. Now, knowing this and going to the upper sum, once again, it's a little bit easier looking at it now. I'm going to change my color on my line to that. Now we need to be entirely above. So A1, we have once again the value of 1 times my function value. Well, if I want to draw it so it's entirely above, and typically what students will do is they'll look at their graph and they'll not do each one of these separately. We'll look at each one and determine where do I want to be entirely above. Okay, so I'm going to draw from here over. Okay, from this point, I'm going to draw from here over because that will be entirely above. I will draw from here over, entirely above. Now this one here, we can sort of visualize it, but sometimes you might have to plug in to see which one's entirely above. So if I look at this, for this region here, that line puts me entirely above the graph of the function. And then my last region over here, entirely above the graph of the function. So what we have here is our function value at the value of negative 1 for this point right here. Now this is at a maximum, and we had 2 points up here. We had 1.5 and negative 0.75. This would be your negative 0.75. So my A2 is going to be 1 times our function value at negative 0.75. This will be my function value at 0. Then we have our function value at 2. And then my last region is my function value at 3. So if we take a look at these values here for the upper sum, I'm going to calculate my values. We have 1 times my function value at negative 1, which is 13. So we have 13 squares here. Negative 0.75 is 14.81. Then we have at 0, which is the value of 3, which gives me 3. Then we have 2, which is negative 23. And then we have the value of 3 is 57. So this gives me my upper sum and this gives me my lower sum. Once again, I need to add down to get my upper sum. So we have 13 plus 14.81 plus 3 plus negative 23 plus 57. So we have the upper sum is 64.81 squares. Now this is quite a spread of data values. Once again, I can shrink down that spread of data values by decreasing my delta x. If I did delta x of 1/2 or 1/4, these values would come once again closer and closer and closer together. So this here is the upper and lower sums when I have a polynomial function. Now what I gave you, I'm not going to do the problem on the back side. You can come back and revisit this one if you want. I gave you a couple problems on a worksheet along with the solutions, very similar to what we just did here. Go ahead, attempt them. Tomorrow we'll start with the other 4. Once again, we have midpoint sum, we have left sum, we have right sum, and we have trapezoid sum. We have 4 more sums to do here, but those tend to be a little bit easier. Your upper and lower sum, you need to have a graph because you need to be able to determine where my line has to go with respect to, is it above the graph or below the graph? You need to determine that. With the left and right sum and midpoint sum and trapezoid sums, you can just use our intervals up here, our subintervals, and be able to calculate those estimates. So go ahead, give the upper and lower sums some tries, work through some of the problems today. Once again, feel free to confer with each other, sit there, FaceTime somebody, and sit there, work on the problems together so you can work through the upper and lower sums. Once again, these tend to be a little bit more difficult. Stay safe, keep your social distancing, maybe enjoy some sunshine today if you get to continue. It's a little chilly outside though, but go out there and get some fresh air maybe, but also get some work done in regards to the upper and lower sums. If you have any questions, feel free to contact or comment me. We'll go over them tomorrow. Adios, yo folks, have a great day. Thank you. I love you. Bye.